video, we are going to teach you how to solve a linear programming model using graphical method.
What is linear programming? Linear programming is a widely used mathematical modeling technique designed to help managers in planning and decision-making relative to resource allocation. This belongs to the broader field of mathematical programming. In this sense, programming refers to modeling and solving a problem mathematically.
So from the problem, we gathered the following data. For alpha 4, the number of labor hours is 20, and for beta 5, the number of labor hours is 25. For alpha 4, the minimum units to produce is 10, and for beta 5, it is 15. The profit per unit for alpha 4 is $1,200, and for beta 5, it is $1,800.
After analyzing the problem and the given data, we make the decision variables. We let x1 be the number of alpha 4 mini computers to manufacture and x2 be the number of beta 5 mini computers to manufacture.
The objective of this problem is to maximize the company's profit. Therefore, it is a maximization problem. To get its objective function, we need to multiply the number of alpha 4 mini computers to manufacture to its corresponding profit per unit and the number of beta 5 mini computers to manufacture to its corresponding profit per unit. So therefore, we came up with the following objective function where maximized profit Z is equals to 1,200 x1 and 1 plus 1,800 x2. The time it takes to produce x1 units of alpha 4 added to the time we produce x2 units of beta 5 must equal to 800 hours. So we came up with the following inequality. The second constraint states that there must be at least 10 alpha 4s produced. So this gives us the linear inequality x1 is greater than or equal to 10. For constraint 3, the third constraint states that there must be at least 15 beta 5s produced. So this gives us the linear equality x2 is greater than or equal to 15. For the fourth constraint, or the non-negativity constraint, the alpha 4s and beta 5s cannot be less than 0. Therefore, x1 and x2 variables must be greater than or equal to 0.
Constraint 1, 20x1 plus 25x2 is equals to 800. When x2 is equal to 0, x1 is equal to 40. And when x1 is equal to 0, x2 is 32. So we got the coordinates. For constraints 2 and 3, we changed the inequality to equal sign. So we got x1 is equals to 10 and x2 is equals to 15.
So here is a graph of all the plotted constraints, and we find the feasible region that satisfies all of the constraints. So it is within this feasible region that we find our optimal solution. We use corner point method to get the points of this region.
So the constraints that intersect at point 1 are constraints 1 and 2. So constraint 1 is 20x1 plus 25x2 equals 800 and x1, and the constraint 2 is x1 equals 10. So using elimination method, we got the following values. x2 is equals to 24, and substituting it to 20x1 plus 25x2 equals 800, so we get x1 equals 100. The constraints that intersect at point 2 are constraint 1 and constraint 3. We will repeat the following process from point 1, and so we will get the following values where x1 is 21.25 and our x2 is equals to 15. We need to calculate the profit by substituting into the objective function. So for point 1, we got z as 55,200 and at point 2, we got 52,500. As we can see, the point with the highest profits is point 1. Therefore, our optimal solution is to produce 10 alpha 4s and 24 beta 5s, which will result in an optimal profit of 55,200.
So here is the final LP model. So from the problem, we gathered the following data. So for shelves, It takes 2 hours of carpentry and 1 hour for painting, with a profit of $15, while on desk, it takes 3 hours for carpentry and 4 hours of painting, with a profit of $40. After analyzing the problem and given data, we come up with the decision variables. We let X be the number of shelves to make and let Y be the number of desks to make. So the objective function of this problem is to maximize profit Z is equals to 15X, which is the number of shelves to make, plus 40Y, which is the number of desks to make. So the constraints of this problem is 2X plus 3Y less than or equal to 60, which is the carpentry restriction, and 1X plus 4Y less than or equal to 40, which is the painting constraint, and XY greater than or equal to 0, which is a non-negativity constraint. So we now draw the graph of the problem. From the first inequality, 2x plus 3y less than or equal to 60. So when y is equals to 0, 2x is equals to 60, and then 60 divided by 2, which now becomes x is equals to 30. And then we plot it here in the x-axis. When x is equal to 0, 3y is equals to 60. 60 divided by 3, it becomes y is equals to 20. And then we plot it here in the y-axis. For the second inequality, 1x plus 4y less than or equal to 40. When y is equals to 0, 1x is equals to 40. 40 divided by 1, x becomes 40. So we plot it here in the graph. So when x is equal to 0, 4y is equals to 40. And then 40 divided by 4, y becomes 10. And then we plot it here. We connect. So we now use the corner point method. So here, which is the 0 and 10, this point is 0, 0. This point is 30 and 0. And then this point, we need to find this. By elimination method, 2x plus 3y is equals to 60. And 1x plus 4y is equals to 40. So we multiply this equation by negative 2. It now becomes negative 2x minus 8y is equals to negative 80. And then copy the previous equation, which is 2x plus 3y is equals to 60. And then we cancel out this one. Negative 8y plus 3y is negative 5y. And negative 80 plus 60 is negative 20. So negative 5y is equals to negative 20. Negative 20 divided by negative 5, y now becomes 4. From this equation, we now find the x. 2x plus 3y is equals to 60 and 1x plus 4y is equals to 40. So 1x plus 4, we now know the y, which is 4. So times 4 is equals to 40. 1x plus 16 is equals to 40. X is equals to 40 minus 16. X is equals to 40 minus 16, which is 24. We now plot 4, which is the y, and 24, which is x, here. We already found the last corner point. Try to figure out how the company will make the most profit. So we now make the profit equation. So let's start with the origin. When x is equal to 0 and y is equal to 0, the company will make 0 profit. And then, when the company makes 30 shelves and 0 desks, they will make $450 of profit. And when they make 0 shelves and then 10 desks, they will have $400 of profit. And then when they make 24 shelves and 4 desks, they will have $520 of profit. So the optimal solution of this problem is that the company will make 24 shelves and 4 desks,
with the profit of $520.